find the standard deviation for the distribution. So we are given lots of xi's, so going from 1 to 2, 1, 2, 3, 4, 5, and then we've got pi's, which are the associated probabilities. So this is a discrete random variable x, a capital X, that can take the values 1, 2, 3, or 5, and each of those values has a corresponding probability and they are not equal. So for instance, the probability of x taking the value 5 is 0.05 or 5%, and so on and so on. So we are going to calculate the standard deviation using a longhand method, and then I'm just going to do it using the calculator feature, which probably I would suggest you'll be doing more often than not. So if you look at the formula book, you are given different choices. If we look at variance of a discrete random variable x, it says var x equals the sum of x minus mu squared times p x equals x. So that is the variance is the mean of the squared deviations approach. So what that means is you need to work out the mean, and then you need to work out the deviation from the mean of each value. So you take the mean away, then you square the deviations to make them positive, and then you calculate the mean of those by timesing them by the p x equals x. So that's one approach. The other approach is the mean of the squares minus the square of the mean. So it's sigma x squared p x equals x. So that's the mean of the squares. When it says x squared, you just take each x value and square it, and then you take away the square of the mean. It's potentially easier, but I'm going to use the first approach, so the mean of the squared deviations approach. So variance, var x, and if you're wondering, well, why is he calculating the variance of x when he's been asked for standard deviation? Remember, the variance is just the standard deviation squared. So once I find the variance, we just square root it for the standard deviation. So variance of x equals the sum of sigma x minus mu squared times p x equals x, just like that. So this is the mean of the squared deviations. So what we are going to need, before we do anything, we're going to need to know, well, what is mu? So our table, we've got all the x values and their corresponding probabilities. The mean, or mu, is given as the sum of the x times the p x equals x. So we're going to have to do that first. So that would be equals 1 times 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. So let's just work that out. Go to our calculator. 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. So that comes out as 2.39. So the mean is 2.39. Now this longhand method for variance is a bit of a pain. So remember, we need to work out the mean of the squared deviation. So for each x, you're going to need an x minus mu, and you're going to need an x minus mu squared. So given that it's a calculator question, I think I might cheat a bit and use a table mode for this. So I'm just going to have, in my table, it's going to be x and then x minus mu. I'm just going to go straight to x minus mu squared and then p x equals x, like that. I'm just going to use the table mode feature to do that. So what I mean by that is, we know the mean's 2.39. So if I go to menu and table mode, number 7, so I need to do x minus mu, 2.39, and then I'm going to square it. Like that, I'm going to set my table. My x's go from 1 to 5 in steps of 1. In steps of 1, and I just look at the table, which saved me a lot of time, although they might not quite fit. So if the first one, 1.9321, and then we have 0.1521, 0.3721, 2.5921, and when x is 5, y is, or not y, x minus mu squared is 6.8121. That's so. Just should fill in the top. That was when x was 1, 2, 3, 4, and 5. If you don't want to do it like this, you could potentially just have one more row, which would be x minus mu. So you could take 2.39 away from all of them, then you could square them all. So the px equals x are just the probabilities that we had from part 1. So it was 0.23, 0.38, 0.21, 0.13, and 0.05. So now, to find the variance, it's the sum of all of these, this number times this. So it's going to be 1.9321 times 0.23, and so on and so on. Add them all up. So this is going to give me the variance. Variance of x equals 1.9321 times 0.23 plus 0.1521 times 0.38 plus 0.3721 times 0.21 plus 2.5921 times 0.13 plus 6.8121 times 0.05. You can see already, even though there's only 5x value, this is it's an incredibly long and tedious thing to do. So I will show you in a minute how you can do this a lot quicker. I'm going to have to do this calculation, which is not the most enjoyable thing, but never mind. So 9321 times 0.23 plus 0.1521 times 0.38 plus 0.3721 times 0.21 plus 2.5921 times 0.13 plus 6.8121 times 0.05. So that gives us an answer for variance of variance of x equals 1.2579. So the standard deviation, or sigma x, standard deviation, must equal the square root of 1.2579. So if we just go to our calculator, square root of the answer, the last answer, that gives us 1.12. And we don't know the units, we don't know what the data is about, so we'll just say that's to 3 sig figs. Now, as I was saying, just think, if you get this in an IB exam, there's just no way you're going to be expected to do something that takes this much time when it's not really mentally taxing. It's repeated calculations. So what you can do is go straight to your table mode on your calculator, not table mode, stats mode. So if we go to statistics, List 1, we just get the original data, put the x's in, 1, 2, 3, 4, 5. List 2, put the probabilities in, 0.23, 0.38, 0.21, 0.13, 0.05. Put them in, go to Calc and go to Setup, and make sure you tell the calculator that this is a frequency table. So it is set up for a frequency table. The X list is list 1, that's fine, that's the variable. And then it says one variable frequency, list 2, so that's right, that means list 2 is the frequency of the X list, which it is, so that's fine. Execute, then we just go to one var, and it comes straight up. We have X bar 2.39, which corresponds with our mu here of 2.39. And we have sigma x equals 1.12, which corresponds with this sigma here. So I would suggest, unless there's a really specific reason that you have to do it a long way around, I would suggest just doing it like this. If you're thinking, well, this isn't a frequency table, it's kind of a relative frequency table, isn't it? But those probabilities can be thought of as relative frequencies. It's if you did this thing a lot of times, say this random variable x represents a physical process or an experiment or something like that, or a game, then over time they would be the relative frequencies you expect of all the individual values of x. So there's absolutely no problem using a frequency table approach at all.